Hello, welcome student in our channel The Physics Point, and in these lectures we are starting discussions of the physics. There are a new topic, that is quantum mechanics. This is the branch of the physics which deals with the electromagnetic wave. We are studying the electromagnetic wave in the subject, that is quantum mechanics. There are different types of the classical mechanics and quantum mechanics. हे दोन वेगवेगळे सब्जेक्ट आहेत. And in the quantum mechanics we are starting discussions of the Heisenberg Uncertainty Principle. Heisenberg Uncertainty Principle. Uncertainty Principle. The Heisenberg Uncertainty Principle states that the uncertainty measurement of the momentum and uncertainty measurement of the positions of the rest particle, when we are taking the product of these two, the uncertainty measurement of the positions of that particle and the uncertainty measurement of the momentum of that particle is greater than or equal to, that is h cut divided by 2, or the uncertainty measurement of the positions of that particles and the uncertainty measurement of the momentum of that particle is greater than or equal to h upon 4 pi. H is the Planck's constant and h cut is the reduced Planck's constant, that is h cut is equal to h upon 2 pi. Okay, when we are substitute the h cut is equal to h upon 4 pi on that place of the h cuts, we get this. Okay, क्या सगळ्या गोष्टी सांगायचं झाले की हा आहे Heisenberg Uncertainty Principle. How can we prove this principle? Okay, let's start discussions of the Heisenberg Uncertainty proof of that Heisenberg Uncertainty Principle or theorem of that. The Heisenberg will be derived this principle in the 1927. The principle is known as the Uncertainty Principle. The most fundamental point on which the conclusion of the quantum mechanics or the wave mechanics. The quantum mechanics is also called the wave mechanics. Quantum mechanics is also called as the wave mechanics. We could not be said. Okay, in the classical mechanics, one can be simultaneously determined as the many property of the particular system. एका सिस्टमचा आपण many property दाखवू शकतो, त्या position दाखवू शकतो, momentum दाखवू शकतो, velocities दाखवू शकतो. But in the quantum mechanics, they could not be possible to showing the many properties of the single system. एखाद्या सिस्टमची many property आपण दाखवू शकत नाही. एखाद्या positions as well as the momentum simultaneously दाखवू शकत नाही. तर या प्रिन्सिपलला अनसर्टनिटी प्रिन्सिपल ऑफ दी हायझेनबर्ग म्हटलं जातं. सपोज अ पार्टिकल ॲट रेस्ट, हा एक पार्टिकल ॲट अ रेस्ट आहे. इफ वी वांट टू सीन दिस पार्टिकल्स, वी वांट हॅव सम फोटॉन एनर्जी किंवा एखादी लाईटची गरज असते एखादा पार्टिकल आपल्याला बघायचे असेल, देन वी वांट टू सी दिस टाइप ऑफ द पार्टिकल विच आर इन द रेस्ट. आय विल बी अप्लाय and strike some photon energy on that particle. काही photon त्या particle वर आपण काय करायचं आहे, strike करायचं आहे. The energy of the photon or the light having the wavelength is lambda. I will strike some photon on that rest particle with their wavelength is lambda. I want to see these particles if the length or distance between the microscope and the particle is more than लॅम्बडा पेक्षा किंवा त्याच्या वेव्हलेंथ आपण जे फोटॉन टाकतो, जे लाईट एनर्जी या पार्टिकलवर आपण टाकतो, जे रेस्टला आहे, त्याच्या आपण जर पाहायचं असेल तर त्याची डिस्टन्स हे त्या लाईटच्या वेव्हलेंथच्या डिस्टन्स पेक्षा जास्त असला पाहिजे. बिकॉज इफ the distance between the particles which are in the rest or which will be taken to consider of that particles and our microscope is shorter than the lambda, there is wavelength of that light which can be applied on that particles because we want to see of that particles in the microscope. Okay, then if the light has the wavelength lambda, we cannot be expected to determine the positions of that particles or the positions or distance of that particles, due to when the lambda is the difference between the microscope and the positions of that particle is shorter than the lambda. Why? Because the main property of that light is diffraction. Light will be diffracted when the distance between the particle and microscope or the source of the light, the particle and microscope is less than the wavelength of that photons which will be applied on that. Okay, then but the photon wavelength has lambda of the momentum. If the wavelength of that lambda, then the momentum of is h upon lambda. H is the Planck's constant. When the photon is collides of that particle, जेव्हा आपण apply केलं तो photon energy which can be collides of that particles, it transfer this much momentum. हा momentum काय होणार आहे? This is the momentum of the wave. This is the momentum of the photon. हा photonचा momentum आहे कारण की ही जी wavelength आहे, this wavelength is of that photon. ती photonची wavelength आहे किंवा त्या lightची wavelength आहे जे आपण apply केलेला आहे. जेव्हा हा collides होतो, हा photon energy collides to the particles, then this much momentum will be transferred. काय होणार? Energy will be conserved किंवा transfer, energy transferred होत जाते. Then the energy will be transferred in that particles and the momentum of that particle is the same, that is p is equal to h upon lambda. हा momentum particleचा देखील असू शकतो आणि त्याचबरोबर अगोदर before the striking on that particles of the photon having the momentum is h upon lambda. Okay, then the product of uncertainty of the positions is, positionचं product काय असणार आहे? Why have we taken the lambda positions and momentum? I have taken position साठी मी लॅम्बडा का घेतलाय कारण की आपलं शॉर्टर डिस्टन्स जे काय लॅम्बडाच असणं गरजेचं आहे. लॅम्बडा पेक्षा जास्त डिस्टन्स असतं म्हणजे पोझिशन किती मिनिमम किती असणार आहे? लॅम्बडा. देन आय विल बी यूज दिस व्हॅल्यू that is h upon lambda into this lambda as it is. Then the product of the positions and momentum of the particles is gives the Planck's constant. Lambda gets cancelled, it gives the Planck's constant. According to the more accurate treatment of the Heisenberg, his principle is stated that if the momentum is known as within the range change in momentum with when the particle moving in the x directions, then change in momentum and the change in positions of the particles in the x direction is greater than or equal to h cut divided by 2, or the change in the positions and change in momentum with respect to x directions is equal to the h upon 4 pi, greater than or equal to h upon 4 pi. Heisenberg Uncertainty Principle is the state that the product of uncertainty measurement of the positions, uncertainty measurement of the positions x, delta x of the body at some instant, and the product of the uncertainty measurement of the momentum at the same instant is greater than or equal to h upon 4 pi, or the greater than or equal to h cut upon 2, and the h cut is equal to h upon 2 pi. This is the relations between the Planck's constant and reducing Planck's constant. Okay, we cannot be measure the simultaneously both the positions and momentum. Okay, ह्या लेक्चरच्या सुरुवातीला देखील सांगितलं होतं की आपण जेव्हा क्वांटम मेकॅनिक्स बघत असतो, वेव्ह मेकॅनिक्स बघत असतो, तेव्हा आपण एखाद्या पर्टिक्युलर सिस्टीमची किंवा एखाद्या पर्टिक्युलर पार्टिकलची मोर दॅन वन प्रॉपर्टी सायमल्टेनियसली मेजर करू शकत नाहीये. या ठिकाणी देखील ते सांगितलं. इफ द वन विल बी इन्क्रीजेस सॅटिस्फाइंग द इक्वेशन्स, हा इक्वेशन सॅटिस्फाय करायचा असेल, आपल्या या दोन्हीचा प्रोडक्ट आहे. जर 3 into 2 is equal to 6 असेल तर 2 into 3 देखील कसं असणार आहे? 6 असणार. इफ द 6 हा सॅटिस्फाय करण्यासाठी म्हणजे h upon 4 pi सॅटिस्फाय करण्यासाठी एक वाढला तर दुसरा ऑब्वियसली कमी व्हायला पाहिजे, दुसरा कमी झाला तर दुसरा ऑब्वियसली वाढायला पाहिजे. दिस इज द सांगितलेलं आहे. both the position and momentum with the perfect accuracy. Upon cannot be determine the positions and momentum of the perfect accuracy if we arrange the matters so that the delta x is small, position is small, then the momentum is large. If the momentum is small, the position is large. This uncertainty is not in our apparatus but in nature. आपल्या apparatus मध्ये नसणार आहे, but this is in our natures. It is not possible to locate the positions of the particle and determine the momentum simultaneously. Again, तेच ते सांगण्यात गेलेलं आहे. The uncertainty principle is state that the product of uncertainty of the positions of that particle and the product of uncertainty momentum of that particle is greater than or equal to h upon 4 pi, where the delta x and delta p are the irreducible minima. Okay, under the circumference, the best things one can be do in the accept of the bone, that is when we start to take on the wave function, since the electrons is must be somewhere in the space, the integrations of this psi mod of psi square then is equal to psi into psi star, that is psi and psi star are the pairs of complex conjugates. Then the integrations, please take in the integrations of the psi star of r and the psi of r is the position vector, they reduced to the unity. Such functions are said to be the normalized function, normalized or normalizing conditions, or normalized to the unity. Yeah, function, such function, that is psi star r and psi r into dr is equal to 1. If the right hand side will be 1, then this condition is a normalizing condition or normalized to the unity. The Heisenberg uncertainty relations. आता हा Heisenberg uncertainty relations आपण positions as well as linear momentum मध्ये बघितला. Angular momentum मध्ये आणि angle मध्ये बघायचं असेल, that is if we are taken the angular momentum and angles, that is delta of L is also greater than or equal to h upon 4 pi, and that is or the delta theta and delta of L is greater than or equal to h cut divided by 2. Okay, why this is when we are substitute h cut is equal to h upon 2 pi, या ठिकाणी आपण सबस्टिट्यूट केल्यानंतर आपल्याला समजून जाईल की काय नेमकं रिलेशन्स आहे. Okay, this is the relations between the Heisenberg uncertainty principle. What is the Heisenberg uncertainty principle? In the quantum mechanics, we could not be explain of the any system there one or more properties simultaneously. Sorry, one or no, two or more property simultaneously. दोन किंवा दोन पेक्षा जास्त प्रॉपर्टी एखाद्या सिस्टीमची आपण सायमल्टेनियसली सांगू शकत नाही या वेव्ह फंक्शन मध्ये, सॉरी वेव्ह मेकॅनिक्स मध्ये किंवा क्वांटम मेकॅनिक्स मध्ये. क्लासिकल मेकॅनिक्स मध्ये आपण एक्सप्लेन करू शकतो. In these topics we are discussing the Heisenberg uncertainty principle when we taken one of the particle here, smallest particles at a rest, एक रेस्टचा पार्टिकल घेतला, त्यावर आपण काय केलं, फोटॉन एनर्जी अप्लाय केला, स्ट्राइक्स ऑन द फोटॉन एनर्जी. व्हाय? बिकॉज वी वांट टू सीन ऑफ दॅट पार्टिकल. एखाद्या पार्टिकल एखादी ऑब्जेक्ट आपल्याला बघायचं असेल तर त्यावर लाईट असणं गरजेचं आहे. त्यामुळे आपण काय केलं, यावर लाईट फोटॉन एनर्जी स्ट्राइक केला. दिस फोटॉन एनर्जी हॅव्हिंग द वेवलेंथ इज लॅम्बडा. If the distance between our microscope and the point or the particle is less than this lambda, या लॅम्बडा पेक्षा कमी असेल तर त्या ठिकाणी काय होणार आहे, ती वेवलेंथ पेक्षा जर आपण अप्लाय केलेल्या लाईट एनर्जी किंवा फोटॉन एनर्जीच्या वेवलेंथ पेक्षा जर त्याची डिस्टन्स कमी असेल तर आपल्याला तो पार्टिकल बघू शकत नाही किंवा त्याची पोझिशन आपण फाइंड आउट करू शकत नाही, ड्यू टू दी मेन that is the property of that light, that is diffraction. And if when a photon energy is strike on that particle, they will be transfer their momentum. Momentum कसं होणार आहे, ट्रान्सफर होणार आहे, having the wavelength and there is Planck's constant. तेव्हा जी काही मोमेंटम ऑफ दॅट पार्टिकल, सॉरी मोमेंटम ऑफ दॅट फोटॉन आहे, ती मोमेंटम ऑफ दॅट पार्टिकल होणार आहे. पार्टिकलची मोमेंटम फोटॉनची मोमेंटम हे कसं ट्रान्सफर झाल्यामुळे पार्टिकलची मोमेंटम हे सॉरी फोटॉनची मोमेंटम हे पार्टिकल मध्ये जाणार आहे. Then what is the exactly Heisenberg uncertainty principle? The product of the positions, measurement of the positions, uncertainty measurement of the positions and the uncertainty measurement of the momentum is greater than or equal to h cut divided by 2 or greater than or equal to h upon 4 pi. This is these Heisenberg equations in the linear motions or linear types of the motions, and when we taken the angle and angular momentum like this. Okay, and taken